So we're going to look at the first problem on the review, which is real simple. I gave you two angles and two sides. This was not arbitrary. You could not simply put the angles wherever you wanted to. Notice I didn't tell you where they went. Why does this situation, why does it have to be A, B, C, and that B and C, if they're both 40, that means that the sides opposite them, AB and AC, those have to be the 10s. Why is that?
Because angles.
You're right.
I don't know how to say it, but I know what I mean.
Correspond.
Yeah.
The angles correspond to each other. That means the bigger the angle, the bigger the side. Or if I have one angle that's 40 degrees in one triangle and I have another angle, then the side lengths have to be equal. We call that an isosceles triangle because that's the way it must happen. So you had to set your triangle up like this. The question was, what's the perimeter? What's perimeter mean? Distance around the outside. Be specific. Okay. So if you work this out, I know that my A is... How do I know what A was 100? If I give you two angles in a triangle, I've already given you all three. So we can set this up using law of sines. Only thing I have to do is find that missing side BC. Turns out it's 15.3. And we can work this all the way out to find the perimeter by adding all three sides together and getting it done. Now, this was a simplistic version of an example, but what I really wanted you to walk away from this with is, can you set up the problem? On the test tomorrow, you're going to have to draw some pictures. Okay? Imagine if on number, let's say, 7, what if I didn't give you the picture, but I described it to you? Could you have set up the picture? If you can set the picture up, then the problems are fine. It's no different than what you did in this review. Okay? So, in light of that, here's my suggestion. Make a note beside these problems. Go back and look at the word problems in sections 5.4 and 5.5. Okay, 5.6 too. Okay, the law of sines section and the law of cosine section. Okay, and I had several online that you can kind of go back through and check out. They have the videos that have me set them up for you. Some of them have pictures drawn for you already. Some of them don't. On the benchmark, there are no pictures. Okay, they're not really complicated problems, but if you can't draw the triangle, label the sides, and figure out what's missing, then you're going to have a hard time. So my suggestion is to go back, practice doing those word problems, and just at least setting up the picture. If you can set the picture up from the description, then you're good to go. Okay, we good? Let's look at... Let's go ahead and look at the next problem, number 7. So, this is one of the ones I told you, attention, that you're going to need to be able to write out the problem. Look at the problem is really simple, but it's 2 steps. Can you connect those 2 steps? I've given you the fact that you have 2 people across from each other. They're 2.32 miles apart. What you want to know, if this is how it's set up, you have a balloon that's up high. You want to know how high the balloon is off the ground. The angle of elevation from A is 28 degrees and from B is 37 degrees. So if we start from that, I need some way to find out H.
What's the, you know how it says the angle?
Use good old Pythagorean.
Not really, because I don't have a right.
You find the side length of one and then you just do sine.
Hold on. Shh. Here's the deal. This is a 2-part problem. It would be great just to use sine, cosine, or tangent to find that, but I can't use that because I don't have... Well, first of all, is that bottom segment cut in half?
No.
It's not, because my angles on the base aren't the same. If they had been equal, it'd been cut in half.
Find there be a reduced sine.
I'm going to have to find... Shh. It is directly between them, but it's not. Doesn't mean the distance is halfway. That's deceiving, but that's what the problem says. So what we're going to do is we need to find AC or AB.
How would the angles be different?
Listen. If I find AB, it does say directly, and that's a little deceiving, but it doesn't mean exactly halfway. Okay, so look at this problem. What we're going to do is we're going to set it up like this. Shh. Why did I say sine 115 over 2.32 equals sine of 28 over A?
It's the whole triangle.
If I can find one of the sides of the triangle, then I have a smaller right triangle to work with. If I have a right triangle, I can use SOHCAHTOA. If I have that, I can use sine as opposite hypotenuse, and then I can work backwards that way to find out exactly how tall the triangle is. That's the only way to do this. You've got to somehow connect yourself to that smaller triangle. Right now, everything you have in terms of side lengths, it's all about the big triangle. So you work it out. Turns out that A is 1.2. Shh, pay attention. Questions so far? So step 1 would be to find the top angle. Step 2 would be to find the side length. Step 3 would be to work backwards, taking sine of 37 equals h over 1.2, which equals 0.72 miles high. I'm looking at that yellow triangle, that right triangle. How do we know it's a right triangle, by the way? How did we know that? Because I didn't tell you that.
You added up. Because it's up. Because you put a little square there.
Technically speaking, because we're measuring height, and when you measure height, you always measure in a perpendicular fashion. So when they talk about how tall is something, you can assume, legitimately, you can assume that it's a 90-degree angle. Otherwise, then it wouldn't make any sense. And so when I work this out, I work backwards to find out exactly, and my answer is 0.72 miles high, which would make sense. You shouldn't be that crazy far off the ground. Questions? Okay, let's look at a couple more. This is number 8. Number 8, we have B equals B equals 35 degrees, A is 43 degrees, or 43 units, and C is 19. This is traditional law of cosines problem. How do we know that it's law of cosines? One of each side. I have an A, I have a B, and a C. That's just straightforward. Let's go right into law of cosines. Okay? If I work backwards and I solve for B, which, listen guys, shh, that's the only thing I can solve for. I have no other options. Okay? I have to go straight to side length B. I work backwards. If you don't know this cosine angle formula, shh, please learn it. Listen carefully. A lot of you are deciding to use the first step in law of cosines, and then you're switching to the law of sines, and you're coming out with the wrong angle, and you're not sure why. It's because you accidentally put yourself in an ambiguous case, and you found the incorrect angle. The only way you're going to realize that is if at the very end you add up your 3 angles and they don't add to 180. Otherwise, you're not going to realize you did it. If you stick with this formula for the area, for the angles, you'll never have that problem. It's just as easy. Once I find this angle, or the side length, I can use this formula to find out any of the angles because I have all 3 sides. So if you work this out, you get 29.5 squared plus 19 squared minus 43 squared over 2 times 29.5 times 19. Turns out that A ends up being 123.4 degrees. And at that point, I can find angle C. How would we find angle C? Because that's really the only thing I have left. I add them together and subtract from 180. The third angle is always the easiest thing to find. Don't forget about that simplistic idea of just subtracting it from 180. Okay? And so therefore you see all the sides and the angles. They gave me 3. I found the first side length to complete all 3 sides. Then I used this formula to find the angle. That's pretty much all the work I had to do. and then I added the other two angles together, subtracted from 180, and that finished off the problem. Questions? I'm making the video as you speak. Yes, there's a... let's go on. The next part is number 9. This one's law of cosines again. Shouldn't be really much a big deal. This is just the straight law of cosines. The good part about law of cosines is it's predictable. It's the same thing every time. I find a side or an angle, and then I find the other angle, and then I'm pretty much done by subtracting from 180.
Why isn't there a more definite way to use signs?
Because you have that one possibility where, what's the reasoning behind law of cosines? Or law of sines is ambiguous. Yes, I showed you you could swing that angle back and forth and make two different triangles. Or it could swing out in the air and never touch the other side, and you've got no triangle. That's why the law of sines, what I tell you about the law of sines is kind of left open and depending on what the other things are. No. Okay, that's number 9. Questions about number 9? This is straightforward, just like this is just like number 8. Okay, I worked it out, tried to finish it out to the other angles. No surprises here. Questions? Dalton, you got a question? No? Okay. Leah, you distracting him?
Can you go back to number 8 on your lead?
Which one?
Go back to number 8 on your pad.
Here's number 8.
Okay, so it is 8 sides.
All right, let's look on at a couple others. These are going to be some of the ones, more of ones that we kind of maybe we haven't talked about a lot, but easy. We did this one yesterday in class. I'll put the solutions back on the board and let you just kind of check your answers. This is the area formulas. Not real surprised here. Real simple, real straightforward. The only thing I have to be careful about here is if you get a problem like this and I ask you to find the area, I might not give you everything that you need. You might have to use the law of sines or cosines one time to get that extra side length or the extra angle and then go right into that formula. Like, for example, I could give you side angle side and ask you for the area of the triangle. Well, if I know both formulas, I could go right into that formula and work it out. But if I have to use Heron's formula, if I only have 2 of the sides, I may have to find that third side first and then work it out. Okay? So there's both 10 and 11. You have your areas. One with sines, one with Heron's formula. Make sure that you know how to use those. Those are pretty straightforward, not complicated. Pretty easy.
They're paying to type out.
What? Yeah. I don't know about the formulas. I'll have to let you know later. I would definitely do note cards to study with so that you got this stuff down so that tomorrow when you have to recall it, it's easier. Okay, let's go on to the next section.
What?
Let me back up a little bit.
That was not a nice look.
Okay, shh, listen. Cosine. Shh, listen. Here we go. 2 cosine x equals 1. I'm going to solve this one simply by dividing by 2 first. Cosine x equals 1/2. How many of you are struggling to remember the unit circle stuff? And that's something you really, really need to focus on tonight. Okay? A lot of people are. Because when I graded the quizzes or the tests prior to this, most people did pretty good, but the people that struggled, they would get to this part. They got here. They had no problem getting here. But it was a matter of, what do I do with the 1/2? And if you stick your left hand up, 1/2 cosine is x. If you put down your 60-degree angle, then that means that I've got a 1/2 left for my left coordinates. And so that means that I'm looking at 60-degree angles in the first and the fourth quadrant. Why first and fourth? Because that's where...
That's what I forgot. I forgot that all strippers take half.
There you go. That just went on the video. That's awesome. So now we're going to have this situation pop up. Pi over 3, which is 60. And then the angle that's in the fourth quadrant, which is also 60, which is 300 degrees, which is 5 pi over 3. All right, let's look at this one. You've got sine of x, or x squared, or sine squared x minus 2 sine x minus 3 equals 0. No substitution needed. This one's ready to go. Ready for you to go ahead and start factoring it. If you factor this one, something's going to happen that you need to be aware of. Okay, you got this one part right here. Sine x equals 3. Not possible. Sine can be no larger than 1 and no less than negative 1. So we just mark it off. The sine x equals negative 1. Just remember sine is y. So where's y equal to negative 1? All the way down on the negative 90 or 270. Shh. Can you get some water? Walk around. Stand up. Definitely not. Cosine 2x equals x, or cos x. You've got this part here. Substitute. Double angle formula. Factor. Work it out. And you've got just like what we practiced before. There's enough of these kind of problems on the test that if you can't do any of them, listen to me, if you can't do those problems, then it's going to really hurt your grade.
How many questions is it?
It's only 20. 19 multiple choice plus one short answer. Can't really
How
tell
do
you.
you
Yeah, how
Ma'am.
would you write that?
short answer, or are we just gonna have to work a problem?
No, I asked you why something. Something like that. Let's do the last problem. Very last one is number 15. Cosine of 2x plus 5 cosine x minus 2 equals 0. Automatically make that substitution. Remember, we want to try to keep the equation in one trig function. All sine, all cosine, not have to do both. If you put into both, then you can't factor it, and it just gets kind of crazy from there. So work it out. You got this part. If it helps you to change that to say it's going to be like 2x or 2 cosine or 2x squared plus 5x minus 3, if that helps you to do that, then don't hesitate. Go right to that, switch it out, finish the problem, switch it back, and you're going to get this part. Here again, we had cosine of negative 3. Not possible. You mark it off. You get cosine x equals 1/2. And so we have x equals, where's cosine equal to positive 1/2? We just had this part of the problem. Okay, it's going to be your 60 and your 300. Now I wrote it in radians because I know that you need practice in radians. I think the test is probably a mixture, so be prepared for both. How do you convert? Pi over 180 to go to radians, or 180 over pi to go to degrees. If you remember that, then you can convert both problems, and you can get it. Make sure that you read through these.